Hello, let's have a look at SmartSPICE and how it differs from some other simulation tools that we might consider using. I'm starting SmartSPICE in the graphical user interface mode. SmartSPICE is a little different from HSPICE and the other tools we might use in that once it's loaded up a file, we can expect to do many commands in that file. The way I work is I create a schematic and then I try many things. I don't submit individual batch jobs to check things out, although that can be helpful when we've finished doing the design. Most of the time I try to invent new things, circuits that work a little better than the average because they have interesting topologies and so forth. And SmartSPICE can help us do that, because SmartSPICE is interactive. We can try different things based on earlier results. If something goes wrong, we change a little something or we try something else. So let me show you how the basic SmartSPICE graphical user interface works. Let's load a circuit into SmartSPICE so we can start to do some work. I'll load up a simple test circuit. SmartSPICE will now read the model files. This is quite a complicated set of model files because it's for the Global Foundries 22 nanometer process, and you can see that SmartSPICE is parsing all of those model files, and it'll take it a little bit of time. It takes it about 20 seconds or so to actually load the model files and the schematic. There we go. There are one or two warnings that have occurred after it's loaded the model file, but this is the circuit that we're using. It's quite simple. It's a few FET devices and a few sources and so on in the circuit. Because SmartSPICE is interactive, we can now begin to ask it some questions about the circuit. The first thing I might want to do is ask it to do an operating point. So the operating point is now completed, and we can look at that operating point data. The operating point data is here, and if I, for example, select them all the different parameters, we can view them and see what we've got. Here are all the operating points of the circuit. So we can study that and see if the circuit came up in the state that we'd expected. And again, because it's interactive, we can now ask SmartSPICE to do an AC analysis. So for example, I can do an AC analysis of this circuit, 100 points per decade from 10 Hertz to, I don't know, 1 gigahertz for instance. And again, SmartSPICE will rapidly complete that analysis, and we can look at the results again in this window. Here are the AC results, and we can, for example, plot the output, the voltage at the output. Let's see if we can find it. The voltage at the output. We can plot that output voltage. SmartSPICE will call for its local plotter to do this. Here we go. That's the output voltage. The voltage is in volts, not logarithmic. Here's an example of a slightly different way to do it. The current plot is the one that's highlighted, that AC analysis. So I can just ask SmartSPICE to plot here. Plot, for example, the dB of the output voltage. That'll be a little bit more like what we expect. Again, it's going to fire up its local plotter, and that's the output. This circuit is configured with a gain of about 1. This is an op-amp with unity gain feedback. One of the tricks I like to do is look at what the equivalent open loop response would be. There are many ways of doing this. One simple way is to just ask, what is the decibel value of the output divided by the difference between the input and the input bar. So I think you can see what I'm doing. The op-amp is operating, the AC analysis was just run, and now I'm asking SmartSPICE to show me the output voltage divided by the difference of the input voltages. This is the open loop response of the amplifier. Notice I haven't had to change the circuit or reload the circuit or do anything. This output in dBs will be more familiar. That, I think, is probably what you expected to see. There's a low open loop gain of only just over 30 dBs, but the phase, as it crosses through zero, we can see it's going to be pretty good. The excess phase starts to come in well below there. This op amp, by the way, is consuming a very small current. In order to ask the question, what is the current that this is consuming? We can go back to that operating point and ask, what was the voltage through VDVCC, and have a look at that, and that was only 3.2 microamps. So this is a very low current op amp and a very simple design. But again, to my point, we're exploring this circuit interactively. We're not having to reload it in any sense. I can ask SmartSPICE to do a transient analysis. Transient analysis, let's say in, I don't know, 10 picosecond steps up to, let's say, 100 nanoseconds, and it should be able to, except I spelt it wrong, it's transient analysis. There we go, done already. Again, let's look at the results we've got in the transient analysis and plot the output, the voltage output. The voltage output is, where are we? There. Plot that voltage output. Remember, it's a unity gain configured op amp. We expect to see the output. Oh, there we go. Look, it didn't move very far. It's slower. I'm running it quite quickly. Look, I'm putting in a signal of about 50 megahertz, and 50 megahertz is well above the crossover frequency. But the point being that that simulation is done and complete. So that's the first point I want to make. The distinction between SmartSPICE and some other simulators is that you can use it in this interactive way without necessarily reloading or predefining all the simulations that you can do.